Let's move on to the next talk. It'll be by Andy Howel from UCSB LCOGT. And he'll be talking of the next generation follow-up ecosystem. Andy, you have got 10 minutes and I'll give you a 2-minute warning.
Okay, thank you. All right, and I just want to point out to people that we don't go by LCOGT anymore, just Las Cumbres Observatory. But
sorry.
No problem. This is a follow-up of the next generation transient follow-up ecosystem. Now, we've already heard of many of these components, so this talk probably should have been first, not last, but that's okay. We'll at least see how these things fit together. So I'm going to take the multi-messenger thing as a use case. We find some transient, we're alerted by various surveys, and then, of course, these things are changing within hours. And so we have to react very quickly. So that changes the type of tools we need. So today, you receive a text-based alert, and then you panic. You start triggering all of the resources that you have access to go and observe it. And you have to look up other resources on the web, or call your friends. If you get data, then you download it from some archive, by clicking some buttons often, and then go and write a text-based circular back to the community. So there's humans in the loop at every step here, and they're slow. And of course, we want to take humans out of the loop where we can and speed things up. So basically today we're here where we've got people switching information around, which is ludicrous in the 2020s. And we want to be here. So we want to have platforms that have standards that anybody can write something, an application to those standards, and then they know how to talk to each other. But we're nowhere near that yet. Okay, so we want to get the alert, have the telescope automatically observe your target, negotiate data access. You don't have to call the director and write some discretionary things. This is all pre-sorted out. The data are automatically reduced, made available to anybody that has access in the community, and then machines and humans make inferences and repeat this process. So this is a very simplified version of the way it's going, of the way I imagine it happening. So you find something with a survey. Let's just assume that's LIGO for the purposes of this talk. Then that information is communicated to brokers or any other thing that might go in there that helps you filter that information. Here are the pipes. Any of these orange arrows could be hopscotch. It gets much more complicated because it doesn't always have to work like this. But we've heard a little bit about a hopscotch, this thing that Sema is working on, a Kafka-based system and libraries, tools for transmitting information. Then you've got other things like treasure map, TOMs, other things that are helping you make decisions based on maybe your resource availability, getting telescopes that you have access to. You trigger something, you get maybe robotic observations. This is where EON and APIs and things come into play. Then data reduced and archived. One of the issues right now is that archives are all set up differently in different clouds or not in clouds, and they don't really talk to each other. Then you want to make an inference based on your data once you have it and are looking at it. And again, this may be back in a TOM, you're looking at it. And then you pass that information back into something like hopscotch or some place so that it can help with the filtering process again. Okay, so we heard a little bit about hopscotch. The idea is, okay, I'm gonna go to this slide first. It's being built by Sema, this NSF funded group to make, possibly think about an institute for multi-messenger astrophysics. It's a PubSub model. I'll talk about that more in a second, but it carries existing astronomical information. So like GCN circulars and notices, transient name server messages, or will, astronomers' telegrams, we hope. But then we'll have its own message format as well that will be a little more flexible, that you can carry other information other than just discovery information. So again, the goal is to increase the machine readability of information and the speed of it and reliability of information. So it's in the cloud, and it's based on Kafka. So it should have high uptime and reliability and all of that. I'll talk about these other things in another slide here. Basically, it's PubSub. So that means that you don't have to carry a limited number of messages. You subscribe to the things you want. Right now, one of the problems is when there's a GCN, when there's an MMA event, there can be hundreds of messages. And sometimes people are writing about multiple events at the same time without an easy way to parse through those. And you're frantically searching through hundreds of messages trying to find what was that circular that said that one thing. But with a PubSub model, you can subscribe to just the things you want. And also you can then publish things like just say light curve points or spectra that don't have to be associated with discovery. You can also publish things like if a resource is available, like an instrument is on a telescope or something. We do envision enabling private messages as well. Okay, then there's the identity and access management. Mario talked about this a bit, but the way we have it currently set up, you can sign in with your existing credentials, and then you tell the system about your collaborations and permissions. You set those up ahead of time. And then so you could even sign up with multiple email addresses. It should know who you are, and then just know how you fit into how your permission systems work. So if this is successful here, we may extend this kind of sign up to Tom Toolkit, Treasure Map, so that again, this whole ecosystem could work on a similar sign-up process. So you don't have to have tons of different identities, which makes it hard for that whole path of sharing data to work. We've heard a lot of talks about Tom, so I'm not going to really go into this. This is just here in case people have some questions. But a place where you could organize your data, have it automatically be reduced, chat with people, have the permissions be understood, get new data easily. This was talked about. Hopscotch and Toms are being integrated together by people in the LCO team who are members of Sema. So this is an example of we're putting GCNs through Hopscotch. The GCN notices are machine readable, so that we started with those. This is X-ray sources that are put out by Swift after a gravitational wave event. And so then this database is reading what's going through Hopscotch, extracting the relevant information, and then putting it in these tables, which we hope to have a bunch of different, a bunch of different views about how to look at that data. Then it has an API. And so here's a case where Treasure Map, which is where people can report what they're observing in this localization region on the sky to help with coordinate follow-up. It can then pull in these X-ray sources. Down at the bottom here, it says XRT sources, and then show you those XRT sources on the sky. So now this is integrating Treasure Map with the Tom Toolkit with Hopscotch all together. And these tooltips can show you this is actually galaxies. So people can report their galaxy follow-up plans to Treasure Map via API. And then this is the X-ray integration. Okay, we do envision planning as part of this whole ecosystem. Resource availability, right now you have to go look at people's calendars on the web for different facilities, but we imagine that being done via API, and Rachel Street has already started with a demo of this. And then of course, there are data lakes where you're gonna want to be able to go and manipulate data. We've heard some talks about that, but there's a lot of work to be done. And we're trying to do some of it in Sema and making databases talk to each other and making things a little bit more standardized. Okay, robotic telescopes are critical to this, and Rachel has already talked about EON, so I'm not going to go much more into that, but I think I'll just stop there and take questions.
Thank you, Andy. I don't see any. Okay, there is a question from Monica. I'm curious about Hopscotch parsing ATELs. Can you elaborate on this?
Yes, the problem with things like ATELs is it's all free text and no machine readability. So this is why we have a two-pronged approach to solving this problem. One, having our own message format that will be machine readable. And in fact, I didn't come back to that slide that I wanted to. Okay, so we're gonna establish our own message format. And right now, I'm going to put together a committee of people in the community that care about this and want to help establish that. So contact me if you're interested. My email's down below there. There's a bunch of open questions that you can see on the screen there. But in the interim, the way we're going to solve it is try to use machine learning to extract information from ATELs, from GCNs, and so on. And so that involves a bunch of humans reading these things, training a model, and then hopefully when there are new messages that people write in free text, we'll be able to extract things like, oh, this is a light curve point. It's in this system. Here's the date of observation. And then we can put that into a database, and then hopefully you'll be able to plot it on graphs in your TOM if it all works. But we have students looking at this right now.
Okay.
And so also, if you're interested in that, we're happy to work with you.
So I think we should move on. I would like to quickly mention that at Caltech, we did do a project where ATEL was extracted through machine learning. And you may also want to see if the current ATELs and GCNs, if there is a way to incorporate your formatedness into them rather than a completely different thing, right? Have you already explored that? You don't have to answer that. Maybe we can take it offline, but I just wanted to make sure that rather than third format, we have that. Okay, so thank you, Gautam and Andy.